my name is Dalton Parker and this is my video for PFTR 1121. Today we're going to be going through the effect of carrying a backpack on posture in adolescent development. So to start, when walking down a hallway in a school, it is a common sight to see students with backpacks filled with books. Carrying books has always been the plight of the student, but it is particularly important to consider when considering adolescent postural development. Today we will be exploring a few points, such as how much is too much for adolescents to carry, what carrying this load actually looks like to deviate their posture, and what is the different carrying techniques used to help compensate for these problems. First, we're going to look at the recommended load carrying amount. It is recommended that no more than 5% of their total body weight be carried in their backpack for females, and no more than 10% of their entire body weight be carried in their backpack for males. In a study done in 2003 by Forhue, Lane, and Schumann, 26% of the students in their survey carried at least 10% of their body weight in their backpack or more. This was regardless of gender. This is problematic because the weight cutoff before load becomes detrimental to adolescent posture development should not exceed 10% of their body weight in females and 15% of their body weight in males. The next point I would like to bring up is the carrying a backpack, what postural deviations it causes. In a study done in 2006 by Hugh, Neal, Smith, Malin, van der Watt, Deacon, and Bester, it was found a small but significant difference when comparing posture carrying a backpack in the cranio-horizontal angle, in the cranio-vertebral angles, as well as a sagittal shoulder posture deviation and a head alignment shift. These postural deviations are not detrimental, but when coupled with the compressive forces from overloading, it can cause musculoskeletal problems. Luckily, to combat these problems, the human body is not a compression model, but a tensegrity model. Tensegrity is an engineering term. Tensegrity means the integrity of a structure through its tensile properties. To best describe this, we look at a compression model compared to a tensegrity model. A compression structure is, think of a building. It is a brick on top of a brick on top of a brick, and it is only as strong as all of its parts. A tensegrity model is this. A tensegrity model resembles the human body. Now, when we put a load on a compression structure that exceeds its lifting capacity, it crumbles. Same with the tensegrity model. When we place a load on it greater than its lifting capacity, it crumbles. But the difference between the compression model and the tensegrity model is the tensegrity model bounces back once the load is removed. Example, we can crush the tensegrity model, but then when the force is removed, it pops back up. Now, the other changes are in the sagittal shoulder posture. Sagittal means differentiating between my left and my right. In proper anatomical position, you can see that my shoulders are level with each other. The next thing we look at is the head alignment. I'll turn sideways, it's easier to see. In head alignment, my head is in line with the rest of my body. The next deviation they mentioned was the cranial-horizontal angle and the cranial-vertebral angle. These, when standing in anatomical position, will be easy to differentiate. What we do is we locate the CT junction. It is the spine process at the base of the neck. Now, what we do is we trace a line anterior and posterior to the body, forward and back. Now, for the cranial-horizontal angle, at the CT junction, it moves straight upwards, bisecting through the head. But the cranial vertebral angle, you find the CT junction, anterior and posterior, and it bisects through the center of the ear. I will explain the deviations when wearing a loaded backpack in the activity that we're going to be doing later in this presentation. The third point I would like to bring up is carrying a backpack. In a study done in 2002 by Goodgold, Corin, Gimshi, Gillis, Gurn, and Coyle, they found that students wore backpacks more on peer evaluation rather than structural integrity. They found that the majority wore their backpacks over one shoulder, and it caused an elevation in the strap supporting shoulder and a lateral bending of the spine to the unweighted side. Although they found that wearing straps over both shoulders helped to disperse the weight more evenly, it still had a negative effect if the students were overloaded. They also postulated in their paper that how the backpack was worn had a significant impact. Was the backpack worn over the largest muscle groups, which are located between the scapula, or was the backpack worn over the smaller muscle groups, which lay on the lower back next to the sacrum? The last point that they made was that how the contents were arranged in a backpack had an effect. The proper way to carry a backpack is the heaviest items are to be placed at the back, closest to the back, and the lighter items to be placed further away. Now, we're going to demonstrate with an activity. For an activity, what we're going to need is a backpack, a bathroom scale, and the contents you might find in an adolescent's backpack. Items that you might find are the lunch bag, a water bottle, gym clothes, books, and a computer. To do this experiment, I performed it on myself just to expedite the process. So, I weigh 159.6 pounds. Being a male, my recommended load carrying amount is 10%. That means my backpack should weigh 15.96 pounds. This is my backpack maximum. Once I put the contents in my backpack and weighed them, my backpack actually came out to 15.6 pounds. That means I was at the maximum amount. I also performed this experiment on a university student. The university student was at the U of A, and she was a female. Her weight was 126 pounds. Being a female, her recommended load carrying amount was 5%. This means her backpack at the maximum should be 6.3 pounds. Her backpack actually weighed 13.4 pounds. This means that she was significantly overloaded, nearly twice the recommended carrying amount. Now, we're going to look at the different postural deviations caused from wearing a loaded backpack. When wearing a backpack, I know as a kid, I would always wear over a single shoulder. Now, as we can see, this does cause a sagittal shoulder deviation, where the strap supporting shoulder has to elevate to compensate for the weight. I turn to the side, we also see that there is a anterior head alignment shift because there is a load placed on my back and I am compensating for the weight. We also will look at the cranial horizontal angle and the cranial vertebral angles. We know that they are anterior to in anatomical position because I have to compensate for the load placed on my back. Now think back to when you were a kid. How did you wear your backpack? Over one shoulder, over two shoulders? Was it high on your back or low on your back? How was the contents arranged? If you can, please do through all of this activity and write down your answers and leave them in the comments section. So to conclude, it can be summed up that a large percentage of school children are carrying bags that are too heavy for them, and then carrying these loads is detrimental to their postural development. Carrying these heavy loads is also causing a deviation. To combat these, proper use when carrying a backpack is important to note, but proper education is being neglected, and it is causing more postural problems later on in life. Thank you very much. This has been my video.